Good morning, my name is Jeff Halonen with Steelhead Technologies, and in this short video we are going to review Redline Job Costing in the Steelhead platform. So first, just a quick overview of what the problem is, and that's with automatic lines tracking job costs. So in a typical job shop environment, we have four basic production modes with job costing for each of them. One is single part task, so we're recording labor and typically no capital, so this would be masking or inspection. So this is typically labor timers and inventory, so very basic stepping parts and billing time against that task. Batch processing is more of parts are in a batch, so heat treating or powder coating many different parts or part numbers or work orders at one time, but we're moving them together as a batch. So there's a number of Steelhead tools to accommodate batch processing. And then manual dip lines as well. This is going to be the scanner lines where we're scanning parts through the tanks, and we can set up our job costing to be customized even down to the tank level, down to the second, tracking the locations of those parts. However, there's a fourth method called automatic line production mode. So this is a carousel or a rack or barrel or conveyor line where the line is moving at a continuous rate, and we're just loading parts in and then taking parts out. So job costing gets very complex and chaotic in this type of space, and this is where the Redline Job Costing tool really shines and is purpose built for job shop automatic line job costing. And that's what the rest of this video is going to cover, is how we do Redline Job Costing. So real quick on when to use the Redline method on most automatic line systems, and when the time to load a single part exceeds the total process time of the station. So for example, if your line, a part goes in, it comes out, that takes 1 hour, but you have 3 hours worth of parts to load, that gets really confusing, because now if you just say, well, the parts are on the line, the parts are off the line, you are now counting it'll now say 4 hours instead of 3 hours worth. So it's really not accurate. And then if multiple parts are being loaded at the same time. So very common, whether it's ergonomics or capacity of your equipment, to load multiple part numbers at the same time into a line. And then also if the lines are not 100% full and we have gaps in between parts that we're processing, we need to capture this information to make sure that we are running our lines as efficiently as we can. So a real quick visual demonstration of what's actually happening here, the physics. And obviously many automatic lines go in circles and are all different shapes, U-shapes, but I just modeled it as a single continuous line just for simplicity here. So we load parts into the line, there's the automatic processing of the parts, and there may be humans in the loop here if we have people powder coating or doing other activities, and there's unloading of parts. So the red line here represents typically a physical red line on the ground to represent this is where we are going to track where parts are at in this process. And then this red box here represents either a tablet or a computer to run the Redline interface. So the idea is really to record how we're using our capacity. So if we have an 8-hour capacity for the day, we want to allocate our costs accordingly to parts as they consume that capacity. So just as a very simple representation here, you can see part A, maybe the first 2 hours is loaded by itself, and then part B and part A are being loaded for a while, and then there's a gap, and then part C is being loaded. So like, how do we record and measure all of that information? That's really where the Redline job costing tool shines. So a line overhead rate is established, and then operators clock into the line, so that way our variable labor and things like natural gas and electricity are all captured. And as our parts essentially consume our production capacity of the line, we are associating that cost accordingly. And of course, the Redline Job Costing tool is distributing this cost in real time, also retroactively, and then any gaps in production are also identified. So I'll show a real quick demonstration of the tool here in Steelhead. So here we have an automatic line for a powder line. So we have staging. This is a typical workboard. So staging of parts. If you're familiar with Steelhead, you know all about the workboards. So you have parts that are in staging, then you have parts that are on the auto line, the parts are perhaps inspected pack, as a simple example. So for example, if we have these parts for Boeing here, we're going to go ahead and step these parts into the auto line. So it's like, hey, we're starting to load these 1,000 parts. We might be loading these for 8 hours, might be loading them for 3 hours. And then also we're loading in these John Deere parts as well. So now we have our parts, both the Boeing parts and John Deere parts in the AutoLine. And now to jump over to what the Redline Job Costing interface looks like. So it'll show the parts in FIFO order as they've been loaded in, and we have the ability to essentially start. Well, we can first see all the instructions that we normally see with photos and things of that nature. But what we can essentially do is at that interface, that Redline interface, we can start that Redline timer. So we can say, hey, we're working on these Boeing parts, and just the Boeing parts, not the John Deere parts. So now we're loading the parts, and maybe for an hour or a half hour, whatever it is, it's capturing that information. But you can see it's calling it out as 100% of the parts are being loaded. However, if after a period of time, and I can come in and add in some other parts just to get a better visual here. So if I add in some of these ABC ink parts, let's put in 200 parts into the line as well. I think these parts are on hold there. But if we start the John Deere parts as well, you can see it's now distributing that cost across these parts here. And then if we hit this little scale here, because it might actually be 50-50, it's taking a guess based on part count, but we can actually modify this as we desire. And then change, we can say, well, it's actually 80% one and 20% the other. We can go ahead and save that. So now in real time, it'll distribute that job cost for both John Deere parts and the Boeing parts. But as we showed in the example, let's say part B or this John Deere part, if we want to, and we can go back and forth between the part number instructions as well. But if we want to step the John Deere parts or part B, we can just go ahead and click step here. You can see that the job costing immediately goes back to 100% Boeing parts. So this is how we are able to track in real time and also historically. So if I actually step this last part, I can either pause the timer, if we have a gap or we're not loading it for whatever reason, or if I want to restart it and step the parts, I can do that. But I can also actually edit these recent timers. So now I can see for this equipment the last 30 minutes, week, hour, whatever it is. So if I do the last hour, I can see you can see it's many short segments here. It's a little bit messy, but we're actually able to modify this and use some pretty intuitive click and drag tools to redistribute the cost based on what actually happened. So there's a bunch of advanced features in here, like splitting as well. So this allows us to look at our production line and accurately model the cost for any period of time. And then just really briefly here, if I jump over to one of these work orders, and this data is not going to look that great, but you can see we have a margin report here, and we have a red line cost. So we can actually see that the timer started and stopped for 29 seconds, 25 seconds, and it has all the costs associated with it, as we discussed previously. So that again is the Redline Job Costing tool, which allows for mixed production on automatic lines and also real-time job costing, as well as those tricky situations where we run a part much longer than the normal processing time. So essentially modeling all of our automated equipment and getting that accurate job costing we're always looking for. Thank you. Have a great day.